Why don't scientists dare to tell you that our world might only be a projection? In 2017, two neutron stars collided in a distant galaxy. Scientists should have celebrated, but instead they fell silent for 3 days. Because they discovered that the way gravitational waves propagated completely violated the predictions of string theory. What does that mean? Those hidden extra dimensions either do not exist at all, or they are far larger than we ever imagined, manipulating the entire universe in ways we cannot perceive. Even stranger, quantum entanglement experiments have repeatedly proven that two particles, no matter how far apart they are, can instantly sense each other's state. This violates the speed of light limit and shatters everything we thought we knew about space. Some physicists have boldly proposed that these particles were never truly separated. They remain tightly bound together, in a dimension we cannot see, and that $10 billion particle collider at CERN may not truly exist to search for the God particle at all, but to attempt to tear open a crack leading to other dimensions. At the moment they create microscopic black holes. Have you ever wondered what they might actually be opening? Today, I want to tell you a truth that mainstream science deliberately avoids. About dimensions, about the nature of our existence, and about why you may never truly leave this universe. The story begins in 1919. That year, a German physicist named Kaluza did something insane. He forcibly extended Einstein's equations of general relativity from 4 dimensions to 5. Everyone thought he had lost his mind. After all, we clearly live in a world of 3 dimensions of space plus 1 of time. Where would a 5th dimension come from? But when Kaluza solved the 5-dimensional equations, something shocking happened. The equations automatically split into 2 parts. One part described gravity, the other part perfectly described electromagnetism. What did that mean? Gravity and electromagnetism, 2 forces that seemed completely unrelated, might actually originate from the same higher-dimensional source. Even more bizarre, Kaluza proposed that the reason we cannot see the 5th dimension is because it is curled up into an extremely tiny circle. Imagine a rope. From far away, it looks like a one-dimensional line, but if you were an ant crawling on the rope, you would discover that it actually has 2 dimensions. One runs along the length of the rope, and the other wraps around its circular circumference. If that circumference were smaller than an atom by 1,000,000,000,000 times, then to us it would be invisible. This was Kaluza's brilliant idea, but at the time, almost no one cared. Because in the 1920s, quantum mechanics was igniting a revolution in physics. Who would worry about an invisible dimension? So the idea was frozen for 60 full years. Until 1984, in the small town of Aspen, Colorado, 2 physicists, Green and Schwartz, solved a fatal problem that had plagued string theory for decades. During a thunderstorm-filled night, they discovered a new mathematical term that made all the probabilities add up to 1 again. This discovery, known as the Green-Schwartz anomaly cancellation, instantly turned string theory into the hottest topic in physics. And string theory predicted that our universe is not 4-dimensional, but 10-dimensional. In addition to the 3 dimensions of space and 1 of time we know, there are 6 extra spatial dimensions. They are curled up at every point in space, in an extraordinarily complex structure called a Calabi-Yau manifold. But here came a terrifying problem. Mathematicians later discovered that the number of Calabi-Yau manifolds that satisfy string theory's requirements is staggeringly large. At first, they thought there were only a few. Now, tens of billions are known. Each different Calabi-Yau manifold corresponds to a different universe, with different physical laws and particles. What does that mean? It means that although string theory is mathematically perfect, it cannot predict why we live in this specific universe, rather than in one of the tens of billions of other possible universes. This is the famous landscape problem that has kept countless physicists awake at night. So do these invisible dimensions really exist? If they do, how large are they? The answer may be hidden in the very first instant of the universe. Scientists believe that after the Big Bang, the universe went through a phase called inflation. In less than a trillionth of a second, the size of the universe expanded by more than 80 orders of magnitude. A region the size of an atomic nucleus, inflated to something larger than Earth. In this extreme process, if extra dimensions truly exist, they should have been created as well. And when inflation ended, the energy of these dimensions would have transformed into special particles, called moduli particles. What makes moduli particles terrifying is that they barely interact with anything at all. Their interaction strength is trillions of times weaker than that of neutrinos. Neutrinos can pass through the entire Earth without obstruction. Moduli particles can pass straight through the entire Milky Way. But precisely because of this, once they are created, they can exist for an incredibly long time. In the first microsecond after the birth of the universe, the entire universe's energy may have been dominated by these moduli particles. Imagine this. In that fleeting instant, our universe was effectively a 10-dimensional world. Those extra dimensions were filled with energy and ruled everything. Then the moduli particles began to decay. Their energy transformed into other particles, including a mysterious particle called the axion. Axions also barely interact with matter. They have been freely flying through space since the birth of the universe, all the way to today. At this very moment, in every cubic centimeter of space around you, there may be hundreds of axions passing straight through. They are the last evidence that extra dimensions once existed. They are the legacy a 10-dimensional universe left behind. Scientists are now using enormous magnetic fields to try to capture these axions. When an axion passes through a strong magnetic field, there is an extremely small chance it will convert into a photon. If we can detect those photons, we will have indirectly proven the existence of extra dimensions. But this is not the strangest part. Remember the quantum entanglement we mentioned earlier? Two entangled particles, no matter how far apart they are, even if one is on Earth and the other in the Andromeda galaxy, will instantly change together. When the state of one is altered, this instantly is truly instantaneous, faster than light itself, violating Einstein's relativity. So how is this non-local effect possible? One bold guess is that, although the two particles appear separated in our three-dimensional space, in higher dimensions they were never separated at all. Like two ants standing at opposite ends of a sheet of paper, they seem far apart, but if you roll the paper up, they might be right next to each other. There is an even more unsettling possibility. What if the extra dimensions are not infinitesimally small, but infinitely large? The gravitational wave observations from the 2017 neutron star collision ruled out extra dimensions of intermediate size, but for extremely small or extremely large dimensions, we are powerless. If extra dimensions are infinite, then gravity may be constantly leaking into them. This could explain why gravity is so much weaker than the other forces. Most of its energy may be disappearing into dimensions we cannot see. And this gravitational leakage could also explain the accelerated expansion of the universe, the mysterious dark energy. Perhaps dark energy is not a new form of energy at all, but merely the echo of gravity in higher dimensional space. Even more wildly, if extra dimensions are truly large, then completely different physical laws may exist within them. In the fifth dimension, time might have multiple directions, allowing you to see every possible outcome of a single event. In the sixth dimension, you could see all universes that started with the same initial conditions, but evolved into different histories. In the seventh dimension, you could even see universes with completely different initial conditions. And in the even higher ninth and 10th dimensions, you would see everything that could possibly exist, past, present, and future. All universes and all possibilities displayed at once. This is why some physicists believe that our universe may truly be nothing more than a projection, like a hologram. Though it is two-dimensional, it contains all the information of a three-dimensional object. Our three-dimensional world may simply be a holographic projection of a higher dimensional reality. This idea is called the holographic principle. It was originally proposed to solve the black hole information paradox, but scientists later realized it might apply to the entire universe. If this is true, then everything we experience, the flow of time, the extension of space, the motion of matter, is merely a form of information encoding, occurring on the boundary of the universe. The real physical processes take place in a higher dimensional space that we can never directly perceive. So is it possible for us to break into these higher dimensions? In theory, if you could generate a sufficiently high energy density, you could bend spacetime itself to its limit, and create a wormhole connecting different dimensions. But the required energy is far beyond the limits of our current technology. Rough estimates suggest you would need to convert the entire mass of the sun into pure energy, just to tear open a crack into higher dimensional space. And even if you succeeded, that crack would collapse and vanish in less than a microsecond. Worse still, no one knows what would happen if you passed through it. You might be compressed into a singularity, or ripped apart into fundamental particles, or even trigger a brand new Big Bang. Yet scientists have not given up. At CERN's Large Hadron Collider, when protons collide at near light speed, an extremely high energy density is briefly created at the collision point. Theory predicts that if extra dimensions exist, such high energy collisions could produce particles called Kaluza, Klein modes. These particles are ordinary particles in higher dimensional space, but in our three-dimensional world, they appear as a series of identical particles with different masses. Even more dramatically, if extra dimensions are large enough, collisions might even create microscopic black holes. But don't worry, these micro black holes would evaporate in less than 10 superscript 2 superscript 3 seconds, without ever touching even a single atomic nucleus. To this day, we still do not know whether extra dimensions truly exist. They may be physics' greatest discovery, or merely a beautiful mathematical illusion. But one thing is certain, If they exist, they are here, right beside you and me, at every point in space. The chair you are sitting on, the air you are breathing, even your own body, may all contain curled six-dimensional spatial structures. Every time you move your finger, that motion does not occur only in three-dimensional space, but also in those invisible dimensions. And within those dimensions, your finger is tracing a path, across a six-dimensional Calabi, Yau manifold, in a way we cannot possibly imagine. Perhaps one day, when our technology is advanced enough, we will truly be able to see these extra dimensions. Perhaps we will discover that the universe is actually a 10-dimensional symphony, and we have only heard 3 notes of it. Perhaps we will discover that time is not a one-way river, but a dimension we can move through both forward and backward. Perhaps we will discover that in some unreachable dimension, there exists another you, making completely different choices, and living a completely different life. And all of these different versions of you truly exist, separated forever by the walls between dimensions, never able to meet. The universe may be far larger, far stranger, and far more beautiful than we imagine, and we are merely standing on the surface of this 10-dimensional universe, peering with 3-dimensional eyes, into an eternal mystery.